Before starting, I would like to suggest you to please make sure your subtitles/CC is turned on for better understanding. Surveying, the first step of starting a new civil engineering project, is a very important branch of civil engineering. To understand the techniques of surveying, a student must carefully study the basics of it. To start learning surveying, one must start with the definition of surveying and its importance. Civil surveying is essential for the success of many construction projects, from residential and commercial buildings to infrastructure. It gives project managers and engineers the geographical information they need to build a structure that will stand up reliably in the local terrain and helps them map out how their project should unfold. Within civil surveying projects, 3D modeling using survey data is a vital technique. The Federal Highway Administration recently analyzed an interchange project in Milwaukee, Wisconsin, and found that the use of 3D modeling reduced operational costs by up to 30.5%, especially in the construction of general structures, drainage, and bridges. But what is civil surveying, exactly, and what different forms does it take for different projects? In this guide, we'll discuss what surveying in civil engineering is, its purpose, and how different types of new technology help accomplish civil surveying goals. Civil surveying is an engineering operation that involves assessing and recording details about an area of land. These observations can then be used to help plan construction projects. The main purpose of surveying in civil engineering is to determine the three-dimensional relationships between different locations. Knowing information like the distances and angles between points and lines helps engineers determine how to draw up plans for public buildings, homes, roads, bridges, and a variety of other construction and infrastructure projects. The points that engineers measure is often located on the surface of the Earth, though they can also be located in space. Because intricate, precise spatial relationships and boundary lines are so integral to this process, civil surveying draws on aspects of different disciplines, from mathematics to geography to law. Civil surveying also involves specific equipment and GPS data acquired from satellites. High-precision electromechanical and optical equipment is also a necessity for ensuring measurements are accurate. So, what is the importance of surveying to civil engineers? Civil surveying is useful in a tremendous variety of different applications, including creating topographical or marine navigational maps, preparing plots, planning for new construction projects, estimating projected paths of roads, railways, power lines and irrigation systems, assessing and recording the boundaries of different properties to determine land ownership, analyzing topography, assessing the position of existing structures like highways, canals, dams and bridges, planning and constructing mines, preparing for military operations and engagements, charting navigational routes. The history of civil surveying goes back to ancient times. Egyptians used geometry to re-establish farm boundaries after dramatic flooding along the Nile River, and they used surveying techniques to design and construct the massive, geometrically precise pyramids at Giza, one of the wonders of the ancient world. During Roman times, the role of civil surveying took on a prominent place in society, becoming an established profession. Land surveyors created the measurement systems they needed to evaluate and create a tax record of the lands they had conquered. In the 18th century, European surveyors developed the technique of triangulation when they realized they could use different angle measurements taken from different places to pinpoint a precise location. And as the British colonized Australia and New Zealand, they used new tools, such as measuring wheels, Gunter's chains, Cater's compasses, and circumferenters, though they also resorted to measuring out paces by foot when necessary. Although construction is the most common type, engineers need to survey a wide range of features, from mountains to oceans to rivers. Engineers use several different types of civil engineering surveys, including construction surveying. Construction surveying is useful for assessing the arrangement of the buildings, roads, power lines, gas mains, and other structures surrounding potential construction sites. Analyzing this information makes it easier to plan construction projects. Deformation surveying. Deformation surveying helps to establish if a geographical or man-made feature, such as a road, foundation, coastline, or river, is changing shape. In deformation surveying, engineers record the three-dimensional coordinates of specific points. After some time has elapsed, they record the coordinates again to see if they have changed. A comparison of the two data sets can reveal if deformation or movement has occurred. Geological surveying. Geological surveying maps out features of the physical landscape, such as rivers, valleys, mountains, and more. Satellite data is essential for geological surveying, and engineers frequently use satellite data or aerial photographs to help them in their work. Hydrographic surveying. Hydrographic surveying is similar to geological surveying, but it maps out coastlines specifically. Accurate hydrographic surveying is crucial to the work of the Coast Guard and any marine rescue operations. It also helps create navigational maps for sailors and assists conservationists in managing coastal resources. Topographic surveying. Topographic surveying analyzes the shape and physical features of a particular landscape. Engineers assess the height of different geographical coordinates and then draw contour lines to indicate areas of the same elevation. They can then use these findings to create topographical maps and to assess terrain for future building or infrastructure projects. Since ancient times, engineers have developed a host of tools to help them survey all types of features. In civil surveying, different types of technology are available, like computer-assisted drawing, CAD. Once engineers have gathered survey data, computer-assisted drawing helps turn that data into a useful visual representation, such as a map or three-dimensional model. CAD allows for a greater level of precision and detail than could not be achieved with manual sketching or drawing. Global positioning. Satellite data, GPS data, is crucial for civil surveying because it allows for the pinpointing of precise locations and coordinates, where a visual assessment alone would be insufficient for determining whether a corner had shifted or a foundation had sunk. The pinpoint accuracy of GPS data allows engineers to know for sure. Aerial photogrammetry. Drones are often useful for the aerial photography necessary in civil engineering. Once they have a number of aerial photographs of the landscape or site in question, engineers can use aerial photogrammetry to extract topographical data from the photos. Aerial photogrammetry combines multiple shots from different angles to create an accurate 3D model. Point cloud modeling. To develop accurate 3D survey models, engineers also often create a point cloud or a set of three-dimensional data points. Surveyors use 3D laser scanning technology to generate a data map of the area they wish to model. Once they have data that represents every surface they need, they can then bring the points together through point cloud modeling into an accurate and detailed 3D model. The knowledge of surveying is advantageous in many phases of engineering. Surveying is of vital importance in any engineering project. Some of the basic importance of surveying is discussed below. The first necessity in surveying is to prepare a plan and a section of an area to be covered by the project. From these prepared maps and sections, the best possible alignment, amount of earthwork and other necessary details depending upon the nature of the project can be calculated. The planning and design of all civil engineering projects such as railways, highways, tunneling, irrigation, dams, reservoirs, waterworks, sewerage works, airfields, ports, massive buildings, etc. are based upon surveying measurements. During execution of the project of any magnitude is constructed along the lines and points established by surveying. The measurement of land and the fixation of its boundaries cannot be done without surveying. The economic feasibility of the engineering feasibility of a project cannot be properly ascertained without undertaking a survey work. The execution of hydrographic and oceanographic charting and mapping requires surveying is used to prepare a topographic map of a land surface of the earth. Please do like and subscribe to my channel and press the bell icon to never miss new video uploads.